All right, today we're going to be talking about arc measure and arc length. So the first part of this is going to be all about arc measures and what we call central angles. So a central angle is an angle whose vertex is on the center of the circle and whose sides are radii. So for example, central angles, all right, are kind of like a piece of pizza and a round pizza. So here's our pizza right there to the side. So a central angle would be CEF. So C angle CEF would be a central angle because of CEF. The vertex, that middle one, is that center. So another example would be angle HEG. Another example could be FEG, or even angle HEC. All right, so anything that goes on the inside there. An arc, all right, is part of the circumference of the circle. It's part of the outside there. All right, so the arc is kind of all around. So all of this area here is the arc because it's part of the outer part of the circle. We have different types of arcs. The first type of arc we have is a minor arc. It's less than 180 degrees, and we use two letters to denote it. So for example here, it tells us that GF, the little arc above it, is a minor arc, G to F. Definitely less than 180. Another example could be HG. Another example could be H to C. We always know and put a little baby arc above it. All right, a major arc is greater than 180, and we use three letters to denote that because we have to make sure we go in a certain order. So bigger than 180, if I start at H to C to F, that one goes right past that. Actually, we'll go a little bit further there. So it goes more than 180, so I could say that HCG is a major arc. I could also say that HGC, the other way around, HGC is also a major arc, and we can kind of keep going and going, listing things. And finally, we have a semicircle. Okay, it measures exactly 180 degrees. It's also denoted using three letters. So exactly half the circle. All right, so half the circle would be something like, not a great example here, from here to here would be a semicircle. Right, but we don't have a great point there to kind of go off of, but a semicircle would be half that. All right, so what we're gonna do is we're gonna use the skills and kind of help us out here. Now remember, the arc, measures of the arc equal the measures of the central angle. So they go kind of hand in hand here. So we have here 42 degrees. That's a central angle. So ARB here is a central angle, 42, which means it's arc. And the arc is, if you look at that thing, it's almost like a mouth here. So this is like our little mouth. In between it, so arc AB here is going to be the exact same measurement of 42 degrees. I can find this angle right here because I can do 180 minus 42, and I get 138, which means that this arc is 138. Over on this side, that's just 180 there because that's the other half of the circle. So see, they want us to know, what is AB? Well, we just said AB is the same as that central angle there, so it's 42 degrees. And it's an arc, so it has a little arc sign. Arc BC. Well, B to C we said was 138. Arc ABC. So let's see. A to B to C. Well, that's half a circle. Half a circle is 180. ACB. So you want to go in order. Let's make this my color. From A to C to B. Well, that's a lot of that circle there. So there's a couple different things we can do there. We can do this 180 plus this 138. If I do 180 plus 138, I get 318. Or I could do 360, the whole circle, minus the part that's not highlighted, which is 42. Regardless, I get 318 either way. This wants to know, determine the measure of the arc intercepted by the angle marked X. So they want us to know, what is this arc measurement here? And we can find that by finding the angle. Now we know this angle right here represents 90, this one's 120, and this one's X. We know the circle adds up to 360, so I can do 360 minus 90 minus 120, and I get 150 is X, which means the arc is going to be the exact same, is going to also be 150. All right, this one says these are diameters. They want to identify everything that we can here, essentially. If I know that this angle right here is 44, I know that this angle across from it is 44 because of vertical angles. I can find the angles next to them by doing 180 minus 44, and I get 136. Okay, first thing I want to know is they want to know what BA is. BA is that arc. All right, look at the central angle. The central angle that has it is that 44, so that arc is going to be 44 degrees as well. BC, B to C. Okay, its central angle is 136, so its arc measure is going to be 136. CD, its central angle is 44, so it's 44. ACB, A to C to B. That's most of this circle right here. So it's all of it but that 44. So I could do 360 minus 44 and get 316. All right, B, C, D. B to C to D. That looks like it's half the circle, so that's going to be 180. And finally, AD. AD, arc AD, is 136. All right, so those are arc measure. Now what we're going to do next is arc length. It wants to know how long is the arc. So not only how many degrees it is, but if I were to stretch it out and actually measure it, how long it is. So we measure it in units of feet, yard, millimeters, etc. The arc length involves the radius and the central angle. And we have this nice formula here to kind of help us out. All right, so our first problem here is they have a measurement of 138 there, or 136, and they got an radius of 8. Okay, the first thing is circumference. Circumference is this equation 2 pi r, so 2 pi. My radius is 8, so I'm going to say 8. And I just multiply like terms, so I multiply that 2 and that 8 together. 2 times 8 is 16, and I just put the little pi right there. And it's going to be in inches. Okay, they want to know how long is the arc AB. So we're going to use that formula that we have up there. So this is theta. Theta just means the angle, the central angle. Well, our central angle is 135. So I've got 135 divided by 360 times 2 pi r, which we said was 16. Oops. We said it was 8. My bad. All right. So if I type this in my calculator, if I do 135 divided by 360, and I do times 2 times 8, all right, and push enter, I get 6. So 6 pi is my arc length. CB. All right, we got to figure out what the angle of CB is. I can do 180 minus 35, and I get 45 degrees there. So we're going to do 45 divided by 360 times 2 pi 8. If I type in parenthesis 45 divided by 360, parenthesis, times 2 times 8, and push equal, I get 2. Add that pi on the end. 2 pi inches. Finally, we've got ACB. So let's see. A to C, whoops, to B. It's this measurement here. Well, we know from A to C, that's half the circle, so that's 180. We know from C to B, that was 45. So if I do 180 plus 45, I get 225. So 225 divided by 360 times 2 pi 8. If I type that, I get 10 pi and then inches. So you're just plugging it into that equation and going from there. And these are what I call the exact answers there. If you want to, you can do 10 times pi into your calculator and you can round to 3 decimal places. This one says, if the central angle is 120 and the diameter is 20 inches, find the arc length. Now, again, we need radius. If the diameter is 20, it means radius is half that. So the radius is 10. So I've got 120 divided by 360 times 2 pi, and my radius is 10. All right, if I type that into my calculator, I get 120 divided by 360 times 20, essentially, and I get 6.66. I can add that pi next to it. If they want exact answer, you can do that 6.66 and do that math frac. Another answer could be 20 over 3 pi. So here's an example of how I do that on my calculator. So if I do parenthesis 120 divided by 360 times 2 times 10, we said, I get 6.66. And if I push the math button and enter, that's how I got that 20 over 3. Now I just add the pi at the very end. All right, this one says the arc length is 10 centimeters. The circle has a radius of 7. To the nearest degree, what is the measure of the arc? So we're kind of working backwards here. So we know that my arc length, okay, my length equals 10. My radius equals 7. We have no idea what that theta is. So if I plug in my equation, I've got 10 equals, we don't know what theta is, times 2 pi, and then 7. All right, so let's see what I can kind of combine here first. 2 times 7 is 14, so I've got 10 equals theta over 360 times 14 pi. My goal is to get theta by itself, so I'm going to do 10 divided by 14 pi, and then times that by 360. So I do 10 divided by 14 pi. Okay, and then times that by 360. Theta is going to be 81.85, and I think they say round to the nearest degree. So if it's 81.85, I'm going to say theta is 82 degrees. All right, this one says determine the radius if the central angle is 100 and the arc length is 6. So we know the arc length is 6. We have no idea what the radius is, but we know theta is 100. So let's plug into our formula. 6 equals theta is 100 over 360 times 2 pi and then r. So I can do 100 divided by 360 and get that decimal. Hold on a second. Sorry, guys. Falling over here. So 100 divided by 360. It's like 0.2777. All right, and I'm going to do 6 divided by that. So let's use our calculator over here. So I've got 6 divided by 100 divided by 360. All right, that gives me 21.6. So I've got 21.6 equals 2 pi r divided by 2 pi. Divide by 2 pi. My answer is 3.438. My radius is 3.438.